One cup of ocean water triples your harvest. Why did we stop using it? It is the secret everyone was taught to fear for more than 50 years. I've had my hands in the soil of American gardens for half a century, watching farming trends come and go. I've seen miracle powders, high-yield fertilizers, and revolutionary one-step solutions. Most of them arrive with a splash and disappear quietly a few years later. But in half a century of planting, pruning, failing, learning, and beginning again, I've discovered something unusual. The things that truly work are often the things people stop talking about. There is one method, one simple, powerful method that works so well it should have transformed American gardening forever. Yet somehow it slipped into the shadows. Most gardeners never heard of it, and those who did were often too afraid to try. We were raised to believe one thing above all, that seawater destroys soil, salt kills crops, salt ruins fields. The warning echoes all the way back to Roman history, when conquerors supposedly scattered salt on defeated lands to make them barren. Generations of gardeners absorbed that fear as unquestionable truth. If it came from the ocean, it didn't belong in the garden. But what if that fear was only a fragment of the story? What if a single cup of diluted ocean water, mixed properly, could double or even triple your harvest? What if it could make plants stronger, more flavorful, more resilient, and more nutritious than anything synthetic fertilizer has ever produced? It sounds unbelievable until you learn that researchers were documenting these results as far back as the 1930s, 40s, and 50s. And it sounds even less unbelievable when you've seen it with your own eyes the way I did. I still remember the day this secret entered my life. It was 1974 at a dusty summer farm fair in the Midwest. I was walking past booths of tractor parts, canning jars, and heirloom seeds when an elderly farmer leaned over and told me he had been experimenting with seawater tomatoes. I thought he was joking or confused, or maybe a little desperate for a good story. But something about his calm confidence stayed with me. That evening, curiosity got the better of me. I decided to try it myself. Behind my old red barn, I planted 2 Cherokee purple tomato plants. Same soil, same sunlight, same water schedule. The only difference was this. One plant received normal water, and the other received a mixture of 1 cup of seawater in 2 gallons of fresh water. The now famous 1:30 ratio. Within weeks, the difference was impossible to ignore. The seawater plant stood taller, its leaves were thicker with a deeper, richer shade of green, while the other plants sagged slightly in the afternoon heat. The seawater plant stayed firm and upright. Even the bugs seemed less interested in it, especially the hornworms that usually find my tomatoes like bees find flowers. Then came the moment that changed everything. About 10 days earlier than expected, the seawater plant produced its first ripe fruit. When I sliced it open, the flesh was dense and beautifully colored. The aroma was deep and almost nostalgic, and when I tasted it, I had to stand still for nearly half a minute. It was that good, rich, sweet, complex. I knew instantly that the garden had just whispered a secret I had been missing for years. The older I get, the more clearly I understand this. Nature rarely hides answers from us. The answers are always there, waiting patiently for us to rediscover them. And if you've spent decades tending a garden, you know this truth in your bones. Sometimes the solution that restores life to the soil is something nature created long before we ever planted our first seed. Sometimes the key to healthier plants, richer harvests, and stronger soil is as simple as 1 cup of ocean water. When we talk about forgotten wisdom in agriculture, the story almost always leads back to one remarkable man. His name was Dr. Maynard Murray, a physician and physiologist born in 1910, a man whose career began not in farm fields but in hospital corridors and research laboratories. He never set out to change agriculture. He simply wanted to understand disease, why it happened, why it persisted, and why some species seem more vulnerable than others. In the 1930s, 40s, and 50s, Dr. Murray devoted his life to studying chronic illnesses. At that time, the medical community was wrestling with rising rates of cancer, arthritis, heart disease, and degenerative conditions. These problems weren't confined to humans. Farm animals and wildlife on land showed the same troubling patterns. Tumors, hardened arteries, inflamed joints. These issues appeared repeatedly in the bodies he examined. It was as if disease itself had become a natural part of life on land. But something didn't add up. Dr. Murray couldn't accept that suffering was inevitable. He believed there had to be a missing piece, something fundamental the medical world wasn't seeing. That conviction pushed him to look somewhere completely unexpected: the ocean. For reasons few understood at the time, he became fascinated with marine animals. These creatures lived under extreme conditions: cold, pressure, predators, parasites. Yet anecdotal reports suggested that whales, dolphins, seals, and many species of fish rarely suffered the same diseases that plagued land mammals. Most people dismiss this as sailors' folklore, but Dr. Murray wasn't most people. He wanted evidence. What followed became one of the most ambitious and meticulous research efforts of the 20th century. Dr. Murray performed thousands of dissections on marine animals: whales hauled from icy northern waters, seals from rugged coastlines, large fish pulled from the deep ocean. He examined organs with a surgeon's precision, searching for the familiar signs he had seen countless times in land animals: cancerous growths, calcified arteries, degenerated cartilage, and the fingerprints of chronic inflammation. The results stunned him over and over. He found that these signs were almost entirely absent. The arteries of sea mammals were clear and flexible. The tissues were healthy and vibrant. Tumors were extraordinarily rare. Even joints, which so often show wear and inflammation in land creatures, were in remarkably good condition. This wasn't an anomaly. It wasn't a lucky sample. His findings remained consistent across thousands of specimens, across different species, across the Arctic, temperate oceans, and the tropics. Whether the animal was young or old, predator or prey, large or small, the story remained the same. Marine life was vastly healthier than life on land. This dramatic contrast forced him to ask a question that would redefine his life's work. Why? Why would animals living under constant environmental stress, cold waters, constant movement, predators, parasites, show almost none of the chronic diseases destroying animals on land? Why would the ocean, of all places, provide a kind of protection we had never been able to recreate on farms or in pastures? Dr. Murray didn't believe in miracles. He believed in physiology, and physiology always has a reason. As he examined mineral content, compared samples, and looked deeper into the chemistry of marine tissues, he began forming a bold idea. The ocean itself held something essential, something present in every drop of seawater, something land ecosystems had slowly lost over millions of years. As he compared the mineral composition of healthy marine organs with the mineral depletion of modern agricultural soils, the connection became impossible to ignore. Land animals weren't just getting sick because of genetics or lifestyle. They were getting sick because the land itself was starving. Soil had lost not just nitrogen or phosphorus, but nearly all of the trace minerals required for true health. Meanwhile, the ocean, layer upon layer of accumulated minerals from rivers, mountains, and ancient stone, had become the most complete mineral reservoir on Earth. This realization became the seed of Dr. Murray's revolutionary insight. The extraordinary health of marine animals wasn't a mystery at all. It was a mineral story. And if ocean minerals protected life in the sea, perhaps they could protect life on land, beginning with the very foundation of our food, the soil beneath our feet. That insight set him on a new path, one that challenged convention and threatened powerful industries. And although much of his work was pushed aside by the rise of commercial fertilizers, the evidence he uncovered — clean arteries, disease-free tissues, robust health across thousands of marine creatures — remains one of the most compelling biological clues ever documented. And it all began with a simple truth we had forgotten: the ocean still holds what the land has lost. To understand why one cup of diluted ocean water can transform a garden, we have to step back not just a few decades, but millions of years. Long before modern fertilizers, long before tractors, long before we learned how to plow a field, the Earth itself was running a quiet, relentless cycle. It was a cycle that shaped the minerals in our soil, the nutrients in our food, and the health of every living creature on land. It begins with something simple: weather. For millions of years, rain fell on mountains and hillsides, dissolving minerals from rock. Every storm, every snowmelt, Every stream and river carried tiny particles of those minerals downhill. Bit by bit, season after season, they washed across forests, plains, pastures, and fields on their way toward the ocean. Every raindrop was a small act of erosion, gently pulling the building blocks of life down to lower ground. Over geological time, this slow and steady process created one of the most important truths about our planet. The land lost minerals and the ocean gained them. As rivers carved through continents, transporting the remnants of ancient stone, the Earth's farmland gradually surrendered its nutrient wealth. The most fertile soils in human history, ancient floodplains, volcanic valleys, and newly exposed glacial deposits, were all created by rare events that replenished minerals. But in most places, the everyday cycle of rain and weather quietly stripped the land of its mineral diversity. Scientists estimate that modern soils have lost more than 80% of the natural trace elements they once held. These are not exotic or mysterious substances. They are the essential micronutrients, things like zinc, boron, iodine, selenium, copper, cobalt, molybdenum, elements required in tiny amounts but with enormous effects on plant immunity, enzyme production, protein formation, and overall vitality. Without them, soil can still grow crops, but those crops are incomplete. They grow fast but not strong, large but not nutrient-rich, green but not resilient. This loss of mineral diversity is one of the reasons pests thrive. Diseases spread easily, and fruits and vegetables today contain fewer nutrients than they did decades ago. In many ways, our soil has become a shadow of what it once was. While the land was losing minerals, the ocean was doing the opposite. Every river on Earth, every trickle of melted snow, every piece of sediment carried downward by gravity eventually found its way into the sea. There, instead of escaping, those minerals accumulated over millions of years. The ocean became the most complete mineral storage system on the planet, a vast, balanced, natural reservoir containing nearly all 92 of the naturally occurring elements found on Earth. This is why Dr. Murray became so fascinated with seawater. To a physiologist, this was not just a pool of salty liquid, it was a blueprint of life. It contained the very elements that build bones, power enzymes, support hormones, strengthen tissues, and regulate every living cell. And it held them in the exact ratios that marine animals, and as he suspected, all animals, needed to maintain health. As Dr. Murray examined the extraordinary health of sea creatures, he began to see the ocean not as a mystery, but as a missing link. Land animals were suffering from the same chronic diseases he saw in his medical practice, while marine animals largely avoided them. The difference was not magic, it was chemistry. The ocean was a complete mineral environment, the land was not. And if this mineral richness could protect whales, seals, fish, and other ocean life from degenerative diseases, then perhaps he thought those same minerals could protect life on land as well. For Dr. Murray, everything pointed in one direction. If we could return the ocean's full mineral spectrum to depleted soil, even in tiny amounts, we might restore the strength, resilience, and nutritional value our crops once had. And if that happened, then animals who ate those crops and people who ate those plants might benefit too. He believed that the ocean was not just a body of water. It was a library of minerals, a complete nutritional archive that held the key to rebuilding the health of our soil, our food, and ultimately ourselves. This was the moment when his medical research took a bold new turn. If the ocean could keep entire ecosystems free from chronic disease, then maybe, just maybe, it could breathe life back into the fields and gardens that had quietly lost the minerals they once held. And that realization, simple, elegant, and backed by millions of years of natural history, became the foundation of everything he discovered next. Once Dr. Murray understood that the ocean held a complete spectrum of minerals missing from our soils, he did what any true scientist and any curious gardener would do. He began to test his theory in the real world. And the place he chose was not a university laboratory. It was a quiet plot of farmland far from the spotlight, where the soil was tired and the plants reflected years of mineral depletion. His method was surprisingly simple. He collected seawater from coastal areas, evaporated it under controlled conditions, and was left with what he called sea solids. the crystallized mineral residue containing nearly the full periodic table. These weren't just salt crystals, they were a concentrated mineral powder rich in magnesium, calcium, boron, iodine, zinc, copper, selenium, cobalt, and dozens of other trace elements the land had lost over time. With this raw material in hand, Dr. Murray began experimenting on a variety of crops, and the results were so striking that even today they read like the claims on a bottle of miracle fertilizer. Except these outcomes weren't created in a factory. They were produced by nature itself. His cornfields became the first sign that something extraordinary was happening. Plants treated with sea solids grew to nearly 10 feet tall, towering above their untreated neighbors. Not only were they taller, but they stood straighter, with thicker stalks and fuller leaves, as if the plants themselves were rediscovering a strength they didn't know they had. Then came the oats. When harvested and analyzed, the protein content in Murray's sea mineral treated oats measured 4 times higher than the local average. 4 times. For any farmer, that is not a small improvement. It is a transformation. High-protein oats mean healthier livestock, more nutritious grain, and an entire food chain elevated because the soil itself was restored. The story continued across crop after crop. Tomatoes grew more vigorously, with richer color and firmer flesh. Grasses and forage crops developed deeper green hues and thicker blades, signaling robust growth. In vegetable plots, everything from lettuce to beans seemed to take on a new vitality. Plants were not just bigger, they were stronger, more resilient, and noticeably healthier. But perhaps the most compelling evidence came from Dr. Murray's animal studies. He fed mice, chickens, and rabbits with food grown on sea mineral-enriched soil. Over time, he observed a remarkable trend. These animals showed fewer signs of disease, their tissues were healthier, their growth more balanced, and they lived with a vigor rarely seen in animals fed traditional feed. These weren't short-term isolated results. They were consistent patterns repeated across multiple trials. Word began to spread. Farmers from surrounding counties visited Murray's fields to see the plants for themselves. Many of them approached with skepticism. After all, seawater had been labeled as destructive for generations. But when they walked through rows of 10-foot corn and inspected the unusually robust grasses, they knew they were witnessing something different. It wasn't a laboratory trick. It wasn't a fertilizer company's marketing promise. It was simply the result of restoring the missing minerals that soil had been craving for decades. Before long, some of those farmers began trying the method themselves. They collected leftover sea solids from salt processing facilities. They experimented with diluted seawater on their own pastures and vegetable gardens. And to their amazement, many of them saw the same improvements Murray had recorded. Stronger plants, deeper color, better resistance to disease, and yields that outperformed anything produced by conventional fertilizers. By the end of the 1950s, Dr. Murray had accumulated an enormous body of evidence, enough to convince anyone who saw it up close that the ocean's mineral blueprint held the power to restore what modern agriculture had lost. His trial fields weren't just healthier, they were models of what farming could look like when the soil was given the full mineral spectrum it needed to thrive. Yet despite the overwhelming evidence, the wider world wasn't ready to listen. But that part of the story comes later. For now, what matters is this. Dr. Murray proved beyond any reasonable doubt that when soil receives the complete set of minerals nature intended, plants respond with strength and vitality that no synthetic product can replicate. And all of it began with the simplest idea imaginable, returning to the land what nature washed into the sea. For a moment, let's imagine a different world, one where Dr. Maynard Murray's discoveries spread across the country in the 1950s, one where farmers everywhere restored their soils with the full mineral spectrum nature originally designed, and one where our food became richer, healthier, and more resilient with every passing season. That world almost existed. It was within reach, but then it slipped away. To understand why, we need to look at what happened in the years after Dr. Murray completed his research. In 1976, he published everything he had discovered in a book titled Sea Energy Agriculture. Inside, he detailed decades of autopsies, field trials, mineral analyses, and crop results. It was a bold work, one that challenged some of the most entrenched beliefs in modern agriculture. Yet despite the overwhelming evidence, the book made only a small ripple. It wasn't because the information lacked value. It was because by the mid-1970s, American agriculture was already moving in a very different direction. This was the era when NPK fertilizers, nitrogen, phosphorus, and potassium, had become the lifeblood of the farming industry. Big companies had perfected the production of these fertilizers, and they were cheap to manufacture, easy to transport, and simple to apply. They fit perfectly into an industrial farming model that prioritized speed and quantity over soil health and long-term resilience. Farmers were told repeatedly and confidently that NPK contained everything crops needed. Scientific institutions reinforced the message, government extension programs echoed it, and because NPK gave plants the fast, leafy growth that looked impressive above the ground, people accepted it. They didn't stop to question what was happening below the surface, how the soil was losing its trace minerals faster than ever before, or how insect pressure and disease were quietly increasing year after year. In an industry where profits depend on repeat purchases, NPK was a dream product. You could patent formulas, brand them, package them in bags, and sell them by the ton. Year after year, crops became dependent on them, soil structure declined, and farms entered a cycle of continuous fertilizer use that guaranteed predictable revenue for manufacturers. But seawater, that was a different story entirely. You can't patent the ocean. You can't own it, package it, or sell it at a premium. You can't lock it behind a brand name. Anyone with a bucket and access to the shoreline could replicate Dr. Murray's method. There was no way to turn seawater into a corporate product, and because it worked so well, it threatened a system built on perpetual fertilizer sales. This is where the story takes a turn many people don't expect. Once NPK became the foundation of commercial agriculture, universities and research programs began receiving heavy funding from fertilizer companies. These partnerships shaped the direction of agricultural research for decades. Most studies focused on optimizing NPK ratios, improving yields within the NPK framework, or developing new synthetic blends to address specific nutrient deficiencies. But almost no one studied the full mineral spectrum of seawater. There was simply no financial incentive to do so. Researchers weren't rewarded for exploring solutions that couldn't be patented or sold. So year after year, generation after generation, agricultural science drifted further away from the natural mineral balance that had sustained life on Earth since the beginning. As the industry pushed deeper into synthetic fertilizers, a new message quietly spread through extension bulletins, academic programs, and farming magazines. Salt is dangerous. Salt kills plants. Salt destroys soil. The irony, of course, is that this message was half true, but only half. It never distinguished between refined table salt, which is almost pure sodium chloride, and seawater minerals, which include more than 90 elements in balanced proportions. The two couldn't be more different, yet they were conveniently lumped together. By oversimplifying the idea of salt, the industry managed to discourage farmers from experimenting with seawater, and the public fear of salting the earth, fueled by dramatic historical stories, did the rest. It created the perfect environment for a quiet misunderstanding to take root. And once that misunderstanding became tradition, it became almost impossible to challenge. So despite Dr. Murray's remarkable evidence, 10-foot corn stalks, protein-rich oats, disease-resistant crops, and healthier livestock, his work drifted into obscurity. It wasn't rejected because it failed. It was forgotten because it didn't fit the business model of the time. That is why most gardeners today have never heard this story. That is why seawater, one of nature's most complete mineral sources, was pushed aside. And that is why the method disappeared, not because it didn't work, but because it worked in a way the industry couldn't profit from. Once you understand this, the rest of the story becomes clearer. It wasn't science that stopped seawater agriculture. It was economics, it was convenience, and ultimately, it was fear. But now that the truth is resurfacing, we have a chance to correct the course and restore to our soil what the rain has been carrying away for millions of years. When Dr. Murray first proposed that ocean minerals could transform soil health, most people saw it as an odd curiosity, something interesting, perhaps even promising, but far outside the mainstream understanding of plant nutrition. Yet as decades passed and science advanced, something remarkable happened. Modern research began confirming, one discovery at a time, exactly why his method works so well. What once looked unconventional is now grounded in some of the strongest plant science we have today. To begin with, seawater contains nearly the full periodic table, 92 naturally occurring elements, each in ratios shaped by millions of years of biological and geological processes. Most fertilizers contain only three: nitrogen, phosphorus, and potassium. A few premium blends add calcium, magnesium, sulfur, or iron, but none of them come close to the mineral diversity locked inside a single drop of ocean water. Plants, just like people, need more than calories to thrive. They need micronutrients, elements required in tiny amounts, often no more than a few parts per million, yet absolutely essential for life. Without these trace minerals, plants may grow, but they cannot build the complex internal systems that give them strength, flavor, immunity, and nutritional value. Take iodine, for example. Most people recognize it as a nutrient for the thyroid in humans, but plants use it too. Iodine helps regulate hormonal signaling, boosts disease resistance, and strengthens natural plant defenses. In soils where iodine has been washed away, which includes most modern farmland, plants struggle to produce their full suite of protective compounds. When the missing iodine returns through sea minerals, the change in plant resilience becomes immediately noticeable. Then there is selenium, one of nature's most potent antioxidants. Selenium protects plant cells from stress, be it drought, heat, cold, or pest attack. In the absence of selenium, plants age more quickly and struggle to repair damage. When selenium is restored, plants remain vibrant for longer and bounce back from environmental challenges with far greater ease. Boron is another quiet hero. It plays a central role in sugar transport within the plant, acting like a highway system that moves energy from where it's made to where it's needed. Without boron, fruits fail to sweeten, roots develop poorly, and blossoms can drop prematurely. Restoring boron through sea minerals allows plants to use energy efficiently, resulting in better fruit quality, stronger root systems, and improved flowering. Copper is equally vital. It activates a wide range of enzymes that control photosynthesis, lignin production, and immune responses. If a plant is low in copper, its ability to convert sunlight into energy becomes compromised. Its stems grow weaker, and its natural defense systems falter. By supplying copper back into the soil, sea minerals help plants build stronger structures and healthier leaves while maintaining a vigorous, balanced metabolism. And then there is cobalt, a mineral many gardeners never think about, yet absolutely essential for legumes like beans, peas, and clover. Cobalt allows nitrogen-fixing bacteria to function properly. Without it, the entire process of turning atmospheric nitrogen into usable plant food breaks down. When cobalt is restored, legumes become the soil-building powerhouses they were meant to be, producing richer biomass and boosting the nitrogen levels of the garden in a completely natural way. Each element on its own plays a small role, but together they form the foundation of plant biology. When all 92 elements are present in the soil, as they are in seawater, plants finally have the full toolbox evolution intended for them. This is when remarkable things start to happen. A plant with complete mineral access builds thicker, stronger cell walls, the botanical equivalent of reinforced armor. These sturdy walls make it harder for insects to chew through and harder for pathogens to invade. At the same time, the plant begins producing more complex proteins and enzymes, molecules essential for growth, flavor, and immunity. These proteins cannot be assembled efficiently without trace minerals. Nitrogen alone cannot build complexity. Plants need the supporting cast. When the mineral foundation is complete, plants become what they were always meant to be: resilient, flavorful, nutrient-dense, and astonishingly self-reliant. Farmers who use refractometers, a tool that measures sugar content in plant sap, often see something extraordinary. After applying diluted seawater or sea solids, Brix values rise, sometimes dramatically. A high Brix reading doesn't just mean a sweeter tomato or melon. It means the plant is converting sunlight into complex carbohydrates, storing energy efficiently, and producing compounds insects can't digest. This is why high-bricks plants naturally repel pests without chemicals. Modern science has revealed a simple truth. Pests are not the cause of weak plants, they are the symptom. They target low-mineral crops because their bodies cannot physically handle the sugars and defenses produced by fully nourished plants. When the soil is rich in trace minerals, the entire ecosystem changes. Plants grow healthier, insects look elsewhere, diseases lose their foothold, soil life returns, nutritional value increases, and gardeners, especially older gardeners who have seen many methods come and go, notice a difference they can feel in their hands and taste on their plates. This is why ocean minerals work, not because they are magical, but because they restore what rain and time have washed away. They return to the soil the full orchestra of minerals that life on land has been missing. And when the orchestra is complete, the music of the garden becomes something extraordinary. As strange as it sounds, one of the most profound clues supporting Dr. Murray's work did not come from a farm, a greenhouse, or a field experiment. It came from medical research more than a century old. Long before modern agriculture narrowed its focus to three chemical nutrients, in the late 1800s and early 1900s, physiologists studying human blood made a discovery so peculiar, so elegant, that it would echo through biology for generations. They found that when you compare the mineral profile of human blood plasma with the mineral profile of diluted seawater, something extraordinary happens. The charts listing every major mineral and many trace elements line up almost perfectly. The ratios are so close, so precise, that early scientists described blood plasma as ocean water that has flowed through the body. These weren't poets. They were chemists working with glass tubes and early analytical tools, trying to understand the chemistry of life. And yet they kept returning to the same conclusion. Our internal fluid is a biochemical reflection of the sea. This wasn't a coincidence or a curiosity. For them, it was a revelation. It suggested that the blueprint for life didn't originate on land at all, but in the ancient oceans where the first cells formed. Over millions of years, as plants and animals slowly migrated onto land, they carried that ocean chemistry inside them, locked into their tissues, their enzymes, their circulatory systems. Every heartbeat, every nerve signal, every cellular repair mechanism still depends on the same minerals that once surrounded early life in the sea. This idea today is known as the ocean memory of life, and it remains one of biology's most beautiful truths. Every creature that walks on land, including us, still carries the chemical signature of the ocean within its body. Our blood hasn't forgotten where life began, and if this is true for humans and animals, it is just as true for plants. Plants may not have blood, but they rely on a fluid transport system that depends on minerals in the same way our bodies do. When you look deeper at the sap flowing through stems, at the mineral cofactors inside plant enzymes, at the delicate chemistry guiding photosynthesis, you find the same pattern. The elements that power life in the sea also power life on land. This is why the ocean's mineral spectrum is so uniquely effective. Plants recognize these minerals because their ancestors evolved in the very environment where these elements existed in perfect balance. In a sense, plants speak the language of the ocean. Their metabolism, their immune system, their root development, and even their reproductive processes were shaped in an environment that had all 92 elements available. When we apply diluted seawater to the soil carefully, gently, at the correct ratio, we are not introducing something foreign or strange. We are restoring something familiar. We are returning to plants the elemental vocabulary they evolved with before erosion and human activity stripped those minerals away. This is why crops respond so dramatically. Their roots instinctively know what to do with these elements. They begin strengthening cell walls, building complete proteins, activating enzymes, and producing natural defenses that chemical fertilizers could never stimulate. The improvement is not artificial or forced. It is simply the plant operating with its full natural toolkit. For older gardeners, people who have watched trends rise and fall, this explanation resonates deeply. We often say that nature remembers even when humans forget, and in this case, the memory is biological. It lives in the sap of every leaf and the roots of every seedling. The ocean is not just a body of water, it is the original pantry of life. It is the mineral blueprint from which all plants and animals descended. And when we return even a fraction of those minerals to the soil, Plants awaken a strength that has been dormant for far too long. This is the quiet miracle behind seawater agriculture. It isn't magic, it isn't folklore. It is biology remembering where it came from and thriving because of it. Now that we understand the science, the history, and the extraordinary potential hidden in ocean minerals, the next question becomes simple. How do we use it safely in the garden? And this is where modern gardeners, especially those of us with decades of experience, often breathe a sigh of relief, because the method is not complicated, not expensive, and not time-consuming. In fact, it is one of the simplest soil building techniques you will ever learn. Everything begins with a single ratio, a ratio tested across thousands of crops and recorded in both Dr. Murray's research and modern university extension guides. If you remember only one thing from this entire video, let it be this: 1 part seawater to 30 parts freshwater. That is the magic formula. In everyday measurements, that means 1 cup of seawater mixed into 2 gallons of clean water. For those who prefer metric, it is roughly 250 milliliters per 7.5 liters. When diluted to this level, the sodium in seawater drops to a safe threshold, while the full mineral spectrum remains intact. This ratio gives plants access to magnesium, calcium, iodine, boron, zinc, copper, manganese, and dozens of other essential elements without exposing them to harmful salt concentrations. The key is precision. Undiluted seawater can damage roots because the salt level overwhelms the plant's ability to draw water. But at the 1:30 ratio, the mineral benefits remain and the risks disappear. It is a careful balance, powerful yet gentle. Once you've prepared your solution, using it correctly matters just as much as mixing it correctly. Always apply the diluted seawater to the soil, never directly to the leaves. The goal is to feed the root zone where microbes, fungi, and plant cells can absorb minerals and incorporate them into the plant's internal systems. When you pour the solution around the base of the plant, the minerals enter the soil ecosystem naturally, just as rain once transported them across ancient landscapes. You only need to do this once every 3 months. That's it. Unlike chemical fertilizers that demand constant application, ocean minerals linger in the soil, supporting both plant health and microbial life long after the watering can is empty. Many gardeners apply in early spring, midsummer, and early fall, creating a gentle mineral rhythm that aligns with natural growth cycles. For those living in dry regions, or those gardening in raised beds or containers where water tends to evaporate quickly, there is one important point to remember. Salt, even at low concentrations, can build up in soils that don't receive much rainfall. The solution is simple: just alternate with a normal watering to flush the soil occasionally. Fresh water dissolves and carries excess sodium downward, ensuring your beds stay balanced. This step is especially helpful in arid climates where rainfall is unpredictable and irrigation replaces natural weather patterns. And perhaps the most important rule of all: never under any circumstances apply pure seawater directly to plants. Full-strength seawater will dehydrate roots within hours, shriveling leaves and stressing the plant beyond recovery. Even salt-tolerant species can struggle. The power of this method comes from dilution, from creating a gentle mineral infusion that mirrors the chemistry of life, not from overwhelming the plant with the ocean all at once. What makes this method so empowering is that gardeners of any age, with any budget, can use it. A simple bucket, a measuring cup, and access to clean seawater or sea mineral products derived from seawater are all you need. And once you've tried it, once you watch your plants deepen in color, strengthen their stems, and resist pests without a drop of pesticide, you begin to understand why those early farmers stared wide-eyed at Dr. Murray's 10-foot corn and protein-rich oats. This is not a fertilizer gimmick. It is not a product of marketing. It is a return to what nature always intended, giving the soil the complete mineral vocabulary it needs to build strong, resilient, nutrient-dense plants. When you dilute it correctly, apply it thoughtfully, and let nature do the rest, the transformation can feel almost magical. But it isn't magic. It's minerals, it's memory, and it's the quiet power of the ocean returning to the land. One of the most surprising, almost unbelievable things that happens when you restore the full spectrum of minerals to your soil is that the garden begins to protect itself. For many gardeners, especially those of us who grew up believing we needed sprays, dusts, and chemicals to fight every insect and disease, this idea feels almost too good to be true. Yet it's one of the most consistent results reported by farmers, gardeners, and researchers who use diluted seawater or sea mineral amendments. And it all begins with something called Brix. Brix is a measure of sugar in dissolved solids in plant sap. You can test it with a simple handheld refractometer. The higher the Brix, the healthier and more nutrient-dense the plant. But the real magic happens when you understand why this matters to insects. Most of the common pests that plague our gardens, aphids, whiteflies, leafhoppers, squash bugs, caterpillars, do not have the digestive enzymes to handle complex carbohydrates. Their digestive systems are extremely simple, designed for weak, undernourished plants that produce basic sugars. When you give plants a full spectrum of minerals, they begin building stronger carbohydrates, longer chains, more complex structures, and richer metabolic products that insects physically cannot process. To us, a high Brix tomato means better flavor. To an insect, a high Brix tomato leaf is indigestible. So the insect does what any creature would do when presented with something it cannot metabolize. It moves on. It doesn't fight. It doesn't adapt. It simply leaves and searches for a weaker plant somewhere else. This is why so many gardeners notice that after a few months of mineral-rich watering, pests become less of a problem. They haven't disappeared from the ecosystem. They've just recognized that your garden no longer offers easy food, and this natural shift isn't temporary. As long as the soil remains balanced and complete, your plants consistently create compounds insects can't digest, making your garden a kind of botanical no-fly zone for pests. Beyond pest resistance, mineral-rich soil gives plants another advantage: thicker, stronger leaves. When minerals like calcium, boron, copper, magnesium, and manganese are abundant, plants build robust cell walls. These tougher structures act like armor plating. They slow dehydration, block viral movement from cell to cell, and create an environment fungi struggle to penetrate. In gardens where diluted seawater has been applied correctly, you'll often notice something subtle but unmistakable. The leaves look heavier, they feel sturdier between your fingers, they hold their shape in wind and direct sun. These aren't fragile leaves vulnerable to powdery mildew or early blight. They're fortified, biologically prepared to resist the stressors that normally wear down a plant through the growing season. Mineral-rich soil also affects fruit development in remarkable ways. When plants have access to all essential trace elements, they produce more vitamins, antioxidants, and organic acids. These compounds not only make the fruit healthier, they make it taste dramatically better. Gardeners often describe these changes using the same words: richer, deeper, fuller, sweeter, more aromatic. A tomato grown in complete mineral soil has a thickness and density you can feel. A pepper becomes more vibrant, more flavorful, almost fragrant when cut open. Even leafy greens take on a cleaner, more complex taste with less bitterness and more vitality. All of these improvements, pest resistance, stronger foliage, enhanced flavor, come from the same biological upgrade. The plant is simply no longer starved. It is finally receiving every element it needs to build itself properly from the inside out. And for older gardeners, this transformation is not just satisfying, it's empowering. Instead of fighting nature year after year with sprays and powders, we can finally work with nature, giving plants the minerals they were designed for and letting the soil do what it once did effortlessly. When the soil is complete, the garden heals itself. And when the garden heals itself, pests will step aside, diseases lose their grip, and the harvest tastes like something from decades ago, back when the soil was still young, still rich, and still whole. For nearly half a century, Dr. Murray's discoveries sat quietly in old bookshelves and forgotten laboratory notes. The world had moved on, fertilizer companies had tightened their grip on agriculture, and seawater, one of the most complete mineral solutions on Earth, was left behind. But beginning in the early 2000s, something remarkable happened. A new generation of growers, researchers, and soil health pioneers rediscovered Murray's work and brought it back to life. The revival began in 2003 when a man named Robert Kane, a close follower and supporter of Dr. Murray's research, launched a product called C90. It wasn't a synthetic fertilizer or a chemical blend. It was simply unrefined sea minerals collected, dried, and packaged in a way that preserved the full spectrum of nearly 90 natural elements. Kane believed so deeply in Murray's mission that he spent years refining the harvesting process along the Baja Mexico coastline, where seawater evaporates cleanly under the sun, leaving behind the mineral-rich crystal powder Murray had once called sea solids. C90 quickly gained attention among gardeners and small farmers who were looking for something safer and more natural than conventional fertilizers. And the stories they shared echoed the results Murray had documented decades earlier. Gardeners saw deeper green leaves, better fruit set, and vegetables with richer, stronger flavors. Pasture managers noticed healthier forage and livestock that thrived on mineral-rich grass. Orchards reported better resistance to late-season diseases and more consistent harvests. It was as if the land itself recognized the minerals it had been missing. Around the same time, another company emerged, Ocean Solution. Instead of extracting only the solids, they created a liquid concentrate that retained the natural mineral balance of seawater while making it easy to apply through irrigation or foliar sprays. Their goal was simple: give farmers and gardeners a way to use ocean minerals without hauling buckets from the shore. And they did so while keeping the product clean, natural, and chemically unaltered. The most astonishing part, both C90 and Ocean Solution were approved for use in certified organic agriculture. This approval did not come easily. Organic certification programs require strict testing to ensure safety, purity, and ecological responsibility. When ocean mineral products passed those standards, it sent a powerful message to the agricultural world. This was not a fringe idea, not a folk remedy, and not an unproven theory. It was real science, natural, deeply rooted in biology, and fully aligned with organic principles. As more farmers adopted these products, real-world data began to accumulate, and the patterns were impossible to ignore. Across the United States, growers reported higher Brix levels, sometimes rising by 3, 5, or even 8 points after a single season. Higher Brix meant stronger plants, healthier sap, more antioxidants, and richer flavor. It also meant fewer insects because pests simply could not digest the complex carbohydrates produced by high Brix plants. Others saw increased yields, sometimes modest, sometimes dramatic. Tomato growers reported heavier clusters and fewer blossom end rot problems. Melon farmers noticed richer sweetness and more consistent ripening. Cattle ranchers, feeding mineral-rich forage, observed animals with shinier coats, steadier weight gain, and fewer health issues. And perhaps most importantly, farmers saw improved resilience. Plants survived heat waves, drought conditions, irregular watering, and disease pressure with greater strength and less stress. This improvement in resilience is something older gardeners understand deeply. A plant raised in balanced soil behaves differently. It stands taller, recovers faster, and produces food with an integrity you can see and taste. What began quietly with Dr. Murray's dissections in the 1930s resurfaced 70 years later in modern organic fields, backyard gardens, orchard farms, and regenerative agriculture circles across the country. The very idea that had once been dismissed, seawater as a complete mineral source, was suddenly being embraced by thousands of growers who cared about flavor, nutrition, soil life, and long-term sustainability. And the reason this revival succeeded is simple. The method works. It always worked. It only needed people willing to listen to what the soil had been asking for all along. Today, ocean mineral products form a bridge between ancient natural cycles and modern sustainable farming. They give growers a way to restore lost minerals without chemicals, without patents, and without harming the land. And perhaps in this era, when the health of our soil and our food is more important than ever, the world is finally ready to hear the message Dr. Murray tried to share so many decades ago. For those of us who have spent a lifetime tending the soil, there comes a moment when we begin seeking something different from our gardens. We want beauty, health, and nourishment, yes, but we also want simplicity. We want methods that work with nature instead of fighting against it. And we want results without the heavy lifting we once took for granted in our younger years. This is where the ocean mineral method becomes not just useful, but truly transformative. For older gardeners, it offers a kind of relief we rarely find in modern gardening advice, a way to grow healthier plants, richer harvests, and stronger soil without bending, hauling, digging, or laboring the way we once did. The first benefit is perhaps the most meaningful. It dramatically reduces physical effort. Applying diluted seawater requires no tilling, no double digging, and no soil turnover. You don't need a wheelbarrow full of compost, and you don't need bags of fertilizer stacked in the shed. All you need is a watering can, a cup, and a clear ratio. With every pour, you are feeding the soil something it can hold on to for months at a time. That simplicity matters as we age. Knees grow less forgiving, backs grow more cautious, and we begin to look for ways to garden smarter rather than harder. The seawater method is one of the few techniques that truly allows this. You don't have to amend 20 inches of soil. You don't have to lift heavy sacks of lime or rock dust. You simply let the minerals soak into the ground and allow nature to carry them where they need to go. Another gift this method offers is freedom from pests without sprays, powders, or constant monitoring. When plants are fully nourished, when their bricks rises and their cell walls thicken, you don't have to chase aphids or battle caterpillars every week. You don't need to crouch under leaves searching for eggs or drag sprayers across the yard. The plants handle much of that work themselves. They defend their own tissues the way healthy bodies do. And as a result, the gardener gets to step back. For older adults, this shift away from fight and toward balance can feel like a breath of fresh air. And while many gardening methods give quick results but drain the soil over time, ocean minerals do the opposite. They restore the soil for the long haul, rebuilding what erosion and chemical fertilizers stripped away. This means that year after year, your garden becomes easier to maintain, not harder. Beds that once compacted easily begin to hold structure. Plants that once wilted in heat recover faster. You may find that the soil takes on a softness and richness you haven't seen since your early gardening days, when farmlands were still young and nutrient-dense. Even more encouraging is how quickly the change arrives. You don't need to wait 5 or 10 years to see improvement. Many gardeners notice deeper color and stronger growth within the first season. By the second season, yields begin rising, flavors deepen, and the soil starts to behave like living earth again. For older growers who don't want to commit to methods that take decades, the near-term results are both practical and deeply rewarding. And perhaps the greatest benefit of all is something quieter, a sense of peace and confidence. When we adopt methods that work with natural rhythms, we feel more grounded in the process. The garden becomes less of a battle and more of a partnership. Instead of chasing pests, we build strength. Instead of forcing growth, we invite balance. Instead of exhausting ourselves, we nourish the soil and let the soil nourish us back. For seniors who love the land and want to keep gardening for many years to come, ocean minerals offer something rare, a way to grow abundant, nutrient-rich food with less strain, less worry, and less labor, all while improving the soil for the next generation. It is a method that honors our bodies, respects our time, and celebrates the wisdom that comes with age. Because in the end, gardening is not about how hard we work the soil, it's about how well we understand it. And this method gives older gardeners a way to garden with the one partner who never stops giving: nature itself. At this point in our journey, you've heard the history, the science, and the real-world success stories. But nothing, truly nothing, builds confidence like seeing results with your own eyes, in your own backyard, with your own hands. And the beauty of the ocean mineral method is that you don't need acres of farmland, fancy equipment, or specialized training to prove it works. You can run a clear, measurable experiment at home, and within a single season, the soil will show you the truth. Begin with something wonderfully simple: 2 pots. They should be the same size, filled with the same soil, and planted with the same variety of seedling: tomatoes, peppers, beans, lettuce. Anything you enjoy growing will do. The goal here is fairness, to eliminate variables and give both plants an identical starting line. Just like the controlled experiments Dr. Murray conducted nearly 70 years ago. Once the seedlings are settled, treat one pot just as you always would. Water it normally, care for it normally, and watch it grow as any healthy plant should. But the second pot, the experimental one, you will water using the 1 to 30 diluted seawater formula, 1 cup of seawater and 2 gallons of fresh water. That's all. Apply the mixture to the soil, not the leaves, and let the roots handle the rest. Then simply observe. Day by day, week by week, the two plants will begin telling different stories. One of them will behave the way plants in mineral-depleted soil usually do, growing reasonably well, perhaps even looking vigorous depending on your soil. But the other will begin to display subtle signs of something deeper happening beneath the surface. This is where a small tool can add clarity, a refractometer. Many seasoned gardeners and orchard growers use it to measure Brix, which reflects sugar content and the density of dissolved nutrients in plant sap. Take a leaf from each pot, squeeze a drop of sap onto the lens, and look through. The plant grown with ocean minerals will almost always show a higher Brix number. That number isn't just a measure of sweetness, it's a snapshot of plant health, how efficiently it is making carbohydrates, how strong its internal systems are, and how complete its nutrient profile looks. As the weeks continue, the differences become visible even without instruments. The leaves on the mineral-fed plant often darken first, taking on a deeper, richer green. Their texture changes too. They thicken, developing a firmness you can feel between your fingers. The stems tend to stand taller, stronger, less prone to bending or wilting on hot afternoons. Then something even more interesting happens. When pests appear in the garden, as they inevitably do, the untreated plant becomes the first target. Aphids collect under the leaves, caterpillars leave chew marks. Tiny sucking insects sap the plant's strength day by day. But the mineral-rich plant? Often it remains untouched. Its Brix is too high for pests to digest, its leaves are too strong for easy chewing, its internal chemistry doesn't allow weak points for disease to slip through. As flowering begins, you'll likely notice another advantage. The ocean mineral plant often buds sooner, produces more blossoms, and transitions to fruiting with smoother momentum. This early vigor translates directly into yield. Earlier harvests, larger harvests, and most importantly, more nutrient-dense produce. When you taste that first tomato or pepper, the difference is striking. The flavor feels fuller, more complex, almost as if the plant had rediscovered an older, richer version of itself. By the end of a single season, the comparison becomes undeniable. Two pots side by side, same soil, same seeds, same sun, same gardener, yet one plant is simply healthier, more resilient, and more productive, and all because it received 1 cup of seawater minerals. This experiment is not complicated, it is not expensive. It does not require youth, strength, or specialized skill. Anyone, especially older gardeners who appreciate slow, meaningful observation, can do it. So I invite you to try it. Not because I want you to take my word for it, or Dr. Murray's word, or any company's claims. I invite you to try it because when you see the difference yourself, the garden becomes a teacher more powerful than any voice in a video. Set up the 2 pots, mix the 130 solution, water 1 plant, and watch. Let the leaves, the stems, the blossoms, and the Brix numbers tell you the story. Because once you witness it firsthand, you will understand why this method survived 7 decades underground and why it is returning now, stronger than ever. As this method begins to make its way back into modern gardening, one thing always happens. People become curious. They lean forward, they want to try it, but they also have questions, concerns, and hesitations. And that's a good thing, because when we ask questions, we're not doubting the method. We're trying to understand it deeply enough to trust it. So in this part, let's walk through the most common concerns I've heard from gardeners over the decades, especially older gardeners who want simplicity, safety, and results they can rely on. The first question almost always sounds the same. I live nowhere near the ocean. What am I supposed to do? It's a fair concern. Not everyone can drive to the coast with a bucket. Fortunately, you don't have to. Nature's solution is portable. You can use unrefined sea salt, sometimes labeled as sea salt for ponds, natural sea mineral salt, or simply non-iodized, unprocessed sea salt. The key is that it must be unrefined. It must still contain the trace minerals that make seawater special. You can also use modern products like C90 or Ocean Solution, both derived directly from seawater and carrying the full mineral spectrum. These options allow gardeners anywhere in the country, mountains, plains, deserts, or suburbs, to access the same benefits as coastal gardeners. The second concern is just as common. What if my soil becomes salty? This fear goes back thousands of years, tied to old stories of armies salting fields to ruin them. But modern science makes the truth clear. Soil only becomes salty if you use the wrong ratio. When you stay with 1 to 30, the sodium level becomes harmless while the beneficial minerals remain abundant. Think of it like seasoning food. A pinch enhances the dish, but a whole spoonful overwhelms it. If you follow the ratio carefully, mineral enrichment happens without raising soil salinity. And in dry regions, a simple flush with fresh water now and then keeps everything in perfect balance. Next comes the most dangerous misconception. Can I just use regular table salt? The short answer is no. The long answer is absolutely not. Table salt is almost pure sodium chloride, about 97 to 99% inositol. Everything else, the magnesium, calcium, zinc, cobalt, iodine, selenium, boron, copper, manganese, molybdenum, and dozens of other nutrients, is removed during the refining process. If you use table salt, you are giving your soil one mineral and depriving it of the other 91 it actually needs. It's the opposite of what plants require. So remember this clearly. Table salt is never a substitute for seawater minerals. Another question gardeners often ask is, how long does it take to see results? Thankfully, not long at all. Most leafy vegetables respond within 2 to 3 weeks. You'll notice deeper color, thicker leaves, and renewed vigor. Fruiting crops, such as tomatoes and peppers, take a bit longer, usually between 4 and 6 weeks, because their root systems and internal chemistry take time to adjust. Pastures and forage grasses typically show full transformation within a single growing season. And once the soil begins to recover, each season becomes easier than the one before. Then there's the soil question. What kind of soil does this work for? The comforting answer is almost all of them. Sandy soil benefits because minerals help hold moisture and support microbial activity. Clay soil benefits because minerals improve structure and aeration. Loam benefits because it regains the trace elements it has slowly lost over time. The only real exception is heavily saline soil, where salt levels are already too high for most plants. But for nearly every garden bed, raised bed, orchard, or pasture, ocean minerals are not only safe, they are restorative. And finally, the question closest to the heart of this channel, is this method suitable for older gardeners? The truth is, this method is almost tailor-made for seniors. It requires no digging, no hauling, no spreading of heavy amendments. It reduces the need for pest control, disease management, and intensive upkeep. It restores soil health without backbreaking labor. And unlike many gardening techniques that demand constant attention, this one works steadily in the background, improving the soil season after season with just a few applications a year. For older gardeners who want to keep growing food, keep staying active, and keep finding joy in their plants without exhausting their bodies, this method is a gift. It allows us to garden with wisdom instead of force, with understanding instead of strain. It respects our experience, it fits our rhythm, and it works quietly, naturally, beautifully. So if you've asked any of these questions, you're not alone. Gardeners across America are asking the same things. And as you now know, the answers are clear, practical, and deeply encouraging. This method isn't just possible, it's accessible, it's safe, it's powerful, and it's ready for anyone to try. As we come to the end of this journey together, there is one truth I hope stays with you long after the video finishes. The soil in your garden is not broken. It is not exhausted beyond repair. It is simply missing pieces. Pieces that nature once provided freely, steadily, and abundantly. When we restore those missing minerals, the soil doesn't just improve, it remembers what it was always capable of. The minerals of the ocean are not magic, and they are not a trend. They are the oldest nutritional foundation on Earth, the original blueprint from which all life emerged. And whether we are talking about plants, animals, or the human body, we all still carry the imprint of that beginning. Our blood mirrors the mineral profile of seawater for a reason. Our cells still operate on that chemistry. Our gardens respond so dramatically because they recognize something deeply familiar. You don't need to overhaul your entire garden to see the truth of this. You don't need to change every bed, every pot, or every routine. All you need is one small experiment, one pot, one plant, one season. Let nature demonstrate its own logic. Let the leaves show you. Let the bricks numbers show you. Let the flavors show you. The moment you see the difference with your own eyes, you will understand why this method refuses to disappear, no matter how often it has been forgotten. And so I leave you with a simple thought, one that has guided me through decades of gardening, observing, and learning. Sometimes the answer isn't found in something new, but in something nature designed at the very beginning of life itself. And if you want to return strength to your soil, to your garden, and to the food you grow, start with something beautifully simple. 1 cup of ocean water. Take this method into your garden, try it in one small pot, and let the soil tell you the rest. I'll be right here cheering you on every step of the way. If this story changed how you view the hidden potential of the sea and the health of your soil, please subscribe and like our channel. We are dedicated to uncovering the history and the natural wisdom that they have tried to bury. Let's plant a stronger future together. The next treasure from nature's archive will be revealed soon.